Hi everyone, my name is Nikhil Satya Surya Datta Vanapalli, representing from CIC section, roll number 20BQ1A4738. So today I'm going to tell about lasers. So first we are going to discuss about Einstein derivations, Ruby laser, HENE gas laser, difference of photography and holography, construction and reconstruction of images. So, light amplification by stimulated emission of radiation. A laser is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. Spatial coherence also allows a laser beam to stay narrow over great distances, enabling applications such as laser points. Types of lasers. There are three types of lasers. Solid laser is nothing but ruby laser, liquid laser and gas laser, which is nothing but HENE laser. Einstein relation. Einstein showed the interaction of radiation with matter with the help of three processes called stimulated absorption, spontaneous emission, and stimulated emission. He showed in 1917 that for a proper description of radiation with matter, the process of stimulated emission is essential. Einstein coefficient for stimulated absorption. Let R1 be the rate of absorption of light by E1 to E2 transitions by the process called stimulated absorption. This rate of absorption R1 is proportional to the number of atoms N1 per unit volume in the ground state and proportional to the energy density E of radiations. That is, R1 is directly proportional to N1E, or it can be also read as R1 equal to B12N1E. This is known as the first equation. Now atoms in the higher energy level E2 can fall to the ground state, even automatically after 10 power minus 8 seconds by the process called spontaneous emission. The rate R2 of spontaneous emission E2 to E1 is independent of energy density E of the radiation field. R2 is proportional to the number of atoms N2 in the excited state E2. Thus, R2 is directly proportional to N2. R2 equal to A21 N2. This is known as the second equation. Next, atoms can also fall back to the ground state even under the influence of the electromagnetic field of an incident photon of energy E2 to E1 equal to hV by the process called stimulated emission. Rate R3 for stimulated emission E2 to E1 is proportional to energy density E of the radiation field and proportional to the number of atoms N2 in the excited state. Thus, R3 is directly proportional to N2E. R3 equal to B21 N2E. This is known as the third equation. Thus, R1 equal to R2 plus R3. Using equations 1, 2 and 3, we get N1B12E equal to N2A21 plus N2B21E, or N1B12E minus N2B21E equal to N2A21, or E equal to N2A21 by N1B12 minus N2B21, that is equal to N2A21 by N2B21 of N1B12 by N2B21 minus 1, or E equal to A21 by B21. This is known as the fourth equation. Einstein proved thermodynamically that the probability of stimulated absorption in is equal to the probability of stimulated emission. Thus B12 equal to B21. Then equation becomes E equal to A21 by B21 of N1 by N1, 1 by N1 by N2 minus 1. This is known as fifth equation. From Boltzmann's distribution law, the ratio of populations of two levels at temperature T is expressed as N1 by N2 equal to E of E2 to E1 E2 minus E1 by KT. N1 by N2 equal to E power hv by KT, where K is the Boltzmann constant and h is the Planck's constant. Substituting values of N1 by N2 in equation 5, we get E equal to A21 by B21 of 1 by E power hv by KT minus 1. This is known as the sixth equation. Now, according to Planck's radiation law, the energy density of the black body radiation of frequency V at temperature T is given as E equal to A pi hv3 by C3 of 1 by E hv by KT. This is known as the seventh equation. By comparing equations 6 and 7, we get A21 by B21 equal to 8 pi hv3 by C3. This is the relation between Einstein's coefficients in laser. So next we are going to tell about significance of Einstein relation. The ratio of Einstein's coefficient of spontaneous emission to the Einstein's coefficient of stimulated absorption is proportional to the cube of frequency V. It means that at thermal equilibrium, the probability of spontaneous emission increases rapidly with the energy difference between two states. So let's discuss about Ruby laser. Ruby laser is a solid state laser that was developed by Maiman in 1960 using ruby as an active medium. Ruby is a crystal of aluminum oxide in which a part of the aluminum ion is substituted by chromium ion. The active material in the ruby is chromium ion. That is, the energy level of chromium ion takes part in the lacing action. Ruby laser construction. Ruby is a crystal of aluminum oxide in which a part of the aluminum ion is substituted by chromium ion. The active material in the ruby is chromium ion. That is, the energy level of chromium ion takes part in the lacing action. The color, pink or red, of ruby crystal depends upon the amount of chromium in it. A crystal of aluminum oxide is specially grown with about 0.05% of the aluminum atom replaced by chromium. Ruby crystals are grown in special furnaces, then annealed and shaped into rods. Such rods are 2 to 30 centimeters in length and 0.5 to 2 centimeters in diameter. Faces of the rod are made strictly parallel, ground and polished to a high degree of precision. Usually the light transmission coefficient of the partially reflecting end face of the ruby rod is about 10 to 25%. Thus, ruby rod with its one end only reflecting and the other end partially reflecting acts as a resonant cavity. Ruby laser working. The ruby rod is arranged along the axis of a helical xenon flash tube in such a manner that the will of the helix encloses the rod. The flash of the tube lasts several milliseconds. During this period of time, the tube absorbs energy amounting to several thousand joules and most of the energy is spent on heating the apparatus. This heat produced is removed by liquid nitrogen circulating around the ruby rod. The remaining part of the energy in the form of blue and green radiation is absorbed by the ruby. This energy ensures the excitation of chromium ion from the ground state to the excited energy state for achieving population inversions. This energy ensures the excitation of chromium ion from the ground excited energy state for achieving population inversion. Raise the chromium ion from ground state E1 to higher excited state E3. These iron interact with the crystal lattice and decay to metastable state E2 by spontaneous emission where they can stay for a longer period, that is from 3 into 10 power minus 3 seconds, producing population inversion. That is the number of chromium ions in the energy state E2, metastable state, is more than the number of chromium ions in excited energy state E3. Hence, population inversion is achieved by optical pumping source. Output of ruby laser. In ruby laser, energy for excitation for population inversion is supplied in the form of short flashes or pulse of light. So ruby laser has a pulse output and hence called pulse laser. Ruby laser has very high output power of the order of 10 power 4 to 10 power 6 watts. It has wavelength of 6943 angstroms. Advantages of ruby laser. It has large power output. The pumping efficiency can be increased by using cylindrical mirrors. It has a narrow line width. And disadvantages of ruby laser. The output laser beam is not continuous but the light is emitted in pulses. The monochromaticity may be affected by crystalline imperfection, thermal distortion and scattering. Frequent cooling is required as a lot of heat energy is produced during its operation. A large amount of energy is required to trigger laser oscillations. Applications of ruby laser. It is used as high power source of pulse coherent radiation in interferometry, radiation interferometry and in pulsed holography. It is used for drilling brittle material, soldering, welding and in-range finding. HENE laser. A helium neon laser or HENE laser is a type of gas laser whose gain medium consists of a mixture of 10:1 ratio of helium and neon at a total pressure of about 1 torr inside of a small electrical discharge. The best known and most widely used HENE laser operates at a wavelength of 632.8 nm in the red part of the visible spectrum. HENE laser construction. Active medium. It is a gas laser which consists of a narrow quartz tube filled with a mixture of helium and neon gases in the ratio 10:1 respectively at low pressure. That is approximately 0.1 mm of Hg. Any atoms act as active centers and responsible for the laser action, while He atoms are used to help in the excitation process. The length of the quartz tube is about 50 centimeters and the diameter is about 1 centimeter. Optical resonator. To construct the optical resonator cavity, two parallel mirrors are placed at the ends of the quartz tube. One of them is partially transparent while the other is fully reflecting. The spacing between the mirrors is adjusted such that it should be equal to the integral multiple of half waves of the laser light. Pumping system. The pumping is done through electrical discharge by using electrodes that are connected to a high frequency alternating current source. Working of HENE. It is a 4 energy level laser system. The electrons produced from electric discharge collide with He and Ne atom and excite them to the higher energy levels He2 and Ne4 at 20.61 eV and 20.66 eV respectively. These two states are metastable, so the atoms may stay there for a longer time. They are very close to each other, thus some of the He atoms at He2 state may transfer their energy to the ground state Ne atoms through collisions and excite them to the higher energy level Ne4. The kinetic energy of atoms provides the additional energy of 0.05 eV. Thus, He atoms helps to achieve population inversion in Ne atoms. The photons that are moving parallel to the axis of the tube will reflect back and forth by the end mirrors of the rod and other excited Ne atoms to radiate another photon with the same phase. Thus, due to the successive reflections of these photons at the end of the tube, the number of photons multiplies. After a few microseconds, a monochromatic, intense and collimated beam of red light of wavelength 6328 angstroms emerges through the partially silvered mirror. HENE laser operates continuously. Holography. It is a technique used to generate three-dimensional images using the phenomenon of interference and diffraction of light. It uses monochromatic and coherent sources of light, and a hologram is needed to regenerate the image. Photography. It is a technique used to generate two-dimensional images of an three-dimensional object. In this, light reflects from the object, strike on the photographic film and react with the chemical coating of the film. A lens is needed to focus the object on the photographic plate. So here you can see the difference between holography and photography. Holography is used to generate three-dimensional images, whereas photography is used to generate two-dimensional images. Phenomenon used in holography is interference and diffraction of light. Whereas in photography, it uses reflection of light by the object to the photographic film. Sources of light should be monochromatic and coherent in holography, whereas in photography, no special type of light source is needed. Holography has high information capacity. Photography has less information capacity than holography. Multiple images can be superimposed together in holography, whereas in photography, multiple images cannot be superimposed together. Construction of image. A weak but broad beam of laser light is splitted into beams by means of beam splitter. One beam directly goes to the photographic film is called as reference beam, and second beam illuminates the object called as object beam. The light scattered by the object moves towards the photographic plate and interferes with the reference beam. The photographic plate carrying complex interference pattern of the object is called holography. The object is stored in the holography in the form of interference pattern. So this is the image. Here you can see the from object waves are transferred to the recording plate. From there, reference wave to the mirror, and here you can see the laser source, and this is the image of holography. Reconstruction of image. A laser beam identical to the reference beam is used for reconstruction of the object. This readout beam illuminates the hologram at the same angle as the reference beam. The hologram acts as a diffraction grating, and secondary waves from hologram interference constructively in certain directions and destructively in other directions. They form a real image in front of the hologram and a virtual image behind the hologram at the original side of the object. An observer sees light waves diverging from the virtual image. An image of the object appears where the object once stood, and the image is identical to what our eyes would have perceived in all its details of the object. And finally, thank you for giving me this opportunity.